This video is going to cover the topic of balancing chemical equations. Before we can balance chemical equations, we must know what chemical equations are. So, here it says that all reactions have the reactants to products format. That's very important because that follows throughout the entire AP Chem curriculum, and that's just how chemistry works. And then it says here, when you are given a reaction in the form of words, which we're going to see in a second, this arrow right here means yields. So you just have to remember that when it says yields, that means that it's time to put the arrow, and then they're starting to talk about the products. There are two main types of representations of chemical reactions, and you see both of them quite a lot. So the first type are word equations. Here they're just going to tell you, let's say, iron plus oxygen yields iron 3 oxide. So from this, you're supposed to make the chemical equation. If they ever give you this, that means, okay, you're going to have to write the chemical equation yourself. Now, sometimes they'll just give you the chemical equation. This happens to be what this would have been. What this would have been in a chemical equation. Now, it's not balanced because, as you can see, here we have 2 irons and here we have 1 iron, which doesn't make any sense. Obviously, that's not balanced. But this is just to show you a representation of what a chemical equation itself looks like. You may have remembered in honors chem or any other chem class maybe that the state of matter was optional. Now in AP Chem, it's kind of optional, but 9 times out of 10, especially when you're going to learn something called net ionic equations, which that comes later on, you're going to have to put these states of matter. States of matter become extremely important in AP Chem because they show you what reactants are used and what state they are. They're just extremely important. Before we can get started balancing equations, we must learn why do we need to balance equations in general, because some people would just want to write the chemicals. Why do we have to go through the extra step, the extra mile, to make sure that it's balanced? Well, the biggest thing is that the law of conservation of matter states that matter cannot be created or destroyed. So in order to hold true to this rule that has been set in place years ago, we have to do this. After writing an equation, the amounts of each reactant must equal the amount of each product. So if we go back to this example, this has 2 irons and this has 1 iron, meaning that that's not equal. So for this one, to just do it really quickly, this isn't the official way of doing it, but for this one, you would probably do 2 iron, but then this has 3. There are 3 oxygens here and 2 oxygens here. So in order to get them equal, we're going to put a 3 here and a 2 here. This has 6 oxygens now and this has 6 oxygens now. But then we just have to modify the iron again, and then we have to put 4 since there are 4 irons here. That's very I am not explaining it, but this is what a balanced equation for this would look like. So that's why after writing an equation, the amounts of each reactant must equal the amount of each product. The unbalanced equation, which if there were no numbers, the unbalanced equation is called the skeleton equation. While I was in class, they never asked for the skeleton equation. That's not useful at all. They never require that. And then there are the coefficients, and the coefficients are basically just these numbers that I put here, and these are the numbers that are used to make sure that the elements on both sides are balanced. So some helpful things to know before we start balancing equations, which will be in the next slide, is to balance equations, a commonly used strategy, which I used throughout the entire thing, was to balance in this order, which is metals, then you move on to your nonmetals, then you move on to your hydrogens, and then you move on to your oxygens. Hydrogens and oxygens are usually, sometimes they give you the most trouble, but oxygens definitely are the ones that will sometimes mess you up or make something look confusing, so you really have to look out for them. You also sometimes diatomics are going to come into play, especially sometimes in single replacement reactions, which will be explained in the next video. So diatomics, you can remember it with either this one or this one. They're both the same. They're just the Hoff is placed in a different place. So you either have Hofbrinkel or Brinkel-Hoff. To remember your diatomics, which are these guys. So Hofbrinkel, it's hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Those are your 1, 2, 3, 4, 5, 6, 7. Your 7 diatomics that you have to just remember. But it's really easy. Hofbrinkel and Brinkel-Hoff will always stay in your head. So this is the part of the video where if you want, you can pause it and try to do it yourself, and then see how I did it and if you got the right answer. So this first question is asking for hydrogen plus oxygen yields water. So this is an example of a word equation, and it's asking us for that. So the first step in any balancing is if they give you words, turn it into a chemical equation like this one below. So hydrogen plus oxygen. Well, some people would do H. Let me change the color. Some people would do H plus O. But that's not correct because you have to remember your diatomics. Your diatomics using Brinkel-Hoff. So both hydrogen and oxygen are diatomics. So you would do H2 plus O2 yields H2O. Now, is this balanced? It does not seem to be balanced because there's two H's and there's two H's, but the O's are unbalanced. So how are we going to get these balanced? Well, you're going to get a 2 here. Because remember, I'll write it on the side. It's metals, nonmetals, hydrogens, and oxygens. So the hydrogens and oxygens in this case, the hydrogens are balanced, but the oxygens are not. So in order to get them balanced, we have to add a 2 here to get 2 oxygens here and 2 oxygens here. But then that means that we have 4 hydrogens and then 2 hydrogens on the left. Meaning that now these are balanced, but these are not. So a simple way is just to add a 2 here, and then you just have to double check, is everything balanced? Well, here we have 4 hydrogens, we have 2 oxygens, and then on this side we have 4 hydrogens, and we have 2 oxygens. So yes, this does seem to be balanced, and you are done with the first example. Now on to example 2. Here, if you were going to read this in words, it would be silver nitrate plus hydrogen sulfide turns into silver sulfide plus nitric acid. So, how would we tackle a question like this? Well, it's the same thing. Just use this thing at the top right here, and you'll be able to balance this. So first, let's balance our metals. So our metals would be the Ags. So are our Ags balanced? No. We have 2 Ags, I mean silver. So we have 2 silver here and 1 here. So in order to balance that, we put a 2 here. Now, nonmetals can also apply to your polyatomics. So usually we look at polyatomics as 1 unit whenever we can. Sometimes if this, let's say, even though it probably wouldn't happen, if this was HNO2, then we wouldn't be able to look at them as polyatomics because this is HNO3 and this is HNO2, and they're 2 completely different things. But since there's NO3 on both sides, we can look at it as 1 unit. So are NO3s balanced? No. NO3 is nitrate. So are nitrates balanced? No, we have 2 nitrates and 1 nitrate here. So what we're going to do to solve that is we're just going to put a 2 here, and now those are balanced. But wait, are my hydrogens balanced? Yes, actually they are. Somehow, when we put the 2 here, it automatically just balanced this one out. And are our S's balanced, our sulfurs? Yes, they are. So this is what the balanced equation would look like. Now on to example 3. This question is asking us for hydrogen plus sulfur turns into hydrogen sulfide. Well, let's turn that into a chemical equation, because that's usually the thing that we use, and that's the thing that will help us get a clearer picture of how to balance. So hydrogen, as we know, is a diatomic. So we have to write that down as H2. Then we're adding sulfur to that. Sulfur is not a diatomic, so it can stay like that. So we have hydrogen sulfur. Then it turns into hydrogen sulfide. Hydrogen sulfide, if you want to take the long way, if you don't know how to figure it out, hydrogen has a +1 charge and sulfur has a -2 charge. So when you put them together and you cross them, you get H2S. So you would plug in the H2S into the products and then check if they're balanced. Here is one example of when you write down the chemical equation, it ends up being balanced because you have two hydrogens, and one sulfur on both sides. So this one you don't even have to do any work, you just have to know how to find an ionic compound from words such as hydrogen sulfide, and then you know that it turns into this. The next example requires a little bit more thinking, but it's still not that hard. So here it says we have iron 3 chloride plus calcium hydroxide yields iron 3 hydroxide plus calcium chloride. In the next video, you're going to know that this is what we call a double replacement reaction, and that ends up yielding a precipitate, and sometimes there is no precipitate, but that's for the next video. This one is called a synthesis reaction. This one is also classified as a double replacement, and this one is also classified as a synthesis. But that's all for the next video, when we're going to be talking about the different types of chemical reactions. It's just good to know how to balance them first and then learn what the different types are, because then that just helps you out even more. So here we go. Just use the strategy that we used before and write this out into a chemical equation. So I went ahead and wrote down the 4 compounds without recording. So this is iron 3 chloride, this is calcium hydroxide, this is iron 3 hydroxide, and this is calcium chloride. The way you figure out what these look like and what the numbers are is just by using your knowledge of knowing how to write ionic compounds. So let's try to balance this. Let's look at our metals first, since that's what we usually do. So our first metal we see is iron. Are ions balanced? Yes. Now we see our calciums. Are our calciums balanced? Yes. We have one on each side. Now the next thing we should look at are our nonmetals. Since chlorine is the first nonmetal we see, let's just go with that one. We have 3 chlorines here and 2 chlorines here. That wouldn't work. So to balance them, we would put a 2 here and a 3 here, because then that would give us 6 chlorines on this side and 6 chlorines on this side. Now, does that put our irons and calciums out of whack? Yes. So what we're going to be able to do to solve that is that we have 3 calciums here, but 1 calcium here. So we have to put a 3 here. And then we have 2 irons here, but 1 iron here. So we're going to put a 2 here. Now let's check our final thing, hydroxides. And when we look at hydroxides, when we balanced the irons and the calciums, it ended up working out, because now we have 6 hydroxides here and 6 hydroxides here. And now you have a balanced chemical equation. And hopefully these examples and this explanation jogged your memory on how to balance chemical equations, and in the next video we're going to be talking about the different types of chemical equations. Thanks for watching.